All right. So, all right. So my next thing I'm going to do is like, we're kind of done with the curriculum right now. At least, you know, from what's in there. We talked about Bayesian and all this stuff. And so my next thing I was going to talk about is the Kaggle competition, right? Like practicing out linear regression, which will lead really well into doing the project itself. And so I was going to kind of give you guys, kind of show you guys what this kind of looks like or what you can do. But since, you know, this is kind of longer than our normal time, do you guys want like a quick 5-minute break, or you guys just want to keep going through and just like power through the next 40 minutes? Yeah. Sorry, go ahead. You guys can talk.
Have a vote, I suppose.
Like a 1 or a 2. Or wait, what were you gonna say?
Yeah. Okay. Here, how about I give you guys thumbs up? Like, yes, let's give a 5-minute break. And thumbs down, being like, oh, let's just power through the next 40 minutes. See people switching around, right? All right. I think most people just want to power through. Just give me a nod if you guys like, let's just keep going through. Okay, cool. All right, we're just gonna keep going through. All right. So, okay. So first of all, you guys know this Kaggle competition. I think some people are already working on it, have been working on it. Give me a thumbs up if you guys have been working on it, at least with your team and stuff like that, like talk about stuff. So I see some thumbs up, cool. All right, and then of course, if you're not part of the team too, you could still do this. Just let me know, because I think you might need a specific link. Right now, I don't think anyone submitted any sample solutions, which I would love to see. Like if you guys want to just, I would say if you guys want to just create a sample solution just for fun, just to see what it does. I think I have the notebook. You could literally take this notebook and try to copy it and just like change it just to see how the submission works. You can submit up to, I think, 5 times in one day. So it's not like you're gonna like lose any time. But I kind of wanted to share with you guys like how you might do this, right? And I think this kind of flows well with how you might do this with, what's it called? Like for your end module project, right? So again, this thing is gonna end on Monday and then we'll start going into our project. But I think the idea of like, you know, you doing linear regression can be useful. Some people have asked, do I need to like, you know, do you need to like document everything really well when you're doing this project? No, like really it's just for you to kind of test things out, but it might be helpful for you to practice documenting your stuff as if you're doing this, but I wouldn't go into full detail. I wouldn't stress out too much about that. It's mostly just you to test out linear regression. Okay, so I have a couple notebooks that I kind of put together. So one is I have this little template. So I'm gonna ask you guys, first of all, I have this template, but I have 2 different notebooks and I can do in essentially 2 different ways. So one, I have a notebook with linear regression already set, but for a different data set, for a different kind of related data set, but not the Kaggle data set. The other option I have is actually I have this data downloaded, and I'm showing an example of how you would do this with this data specifically. It's a very simple solution. And then the third option really is we can do like, for example, like the data set here, but I do it from scratch versus something that's prepared. So any feelings on what you guys would like? So one being, I have to do this whole funny thing. So one being that I have it pre-prepared for the this data set. Number 2 is pre-prepared but with a different data set. And 3 being doing it from scratch, whether that's the first data set or the Kaggle data set. So 1 is the Kaggle data set pre-prepared, 2 is a different data set but pre-prepared, and 3 is do it from scratch. Okay, I see Jessica did 2 or 3, and I think that's how I'm interpreting that. I see 3 from Andy, I see Akiva 2 and 3, I see Mike with 2, and I see Alvaro with 3. Okay, so I think most people say 3, so they say, Victor, code, you monkey. All right, let's hear. So let's hear. I think this is the one I pre-prepared. Is this? Yeah, so I'm gonna go ahead and start from scratch. So this template, which I have this uploaded on the, one of the branches on the repo. I'll make sure to put this and merge it onto the main branch. So that way you guys can use this template if you guys like it, but you don't have to. So, all right. And the reason why I pre-prepared stuff too is because I wanted to make sure in case I got stuck, which I happen sometimes, go forward. Was there a question? I think I saw Jessica.
I have a question.
Yeah.
So do we like download the data and then do this in our Jupyter notebooks, or do we use the notebook that's on there that we like share?
Yeah, so you can either do a notebook directly from here, like create a new notebook and do it from there, and then down, like I think you can even submit through the notebook, but you could then download, what the prediction is going to be and then upload it on here. Another way you can do it is just do it with, I would suggest doing it with with Jupyter Notebook, just because you guys have been using Jupyter Notebook and that's what you'll do the main project with. And you can basically download the data, interact with it, make your predictions, and then just submit the solutions for your leaderboard here. Does that make sense?
Okay, cool. Yeah.
And so that's what I'm going to do. So I'm going to show you guys what that looks like. So I have the data here, and I'm going to do a really simple, straightforward thing as best I can, because we have about 30 minutes. So we'll see how we do. I'm going to go ahead and download, let's say, test CSV, and then I'll download train CSV, right? So I think it comes out as, I don't know what it comes out as zip, but I can download these data sets, and I can then move them everywhere. So I already did that because I didn't want to do it later, but I created like data and then Kaggle comp and then test.train CSV. Okay, so I have that data set, and I'm just going to use this template here. I don't have it filled out, but we'll go through. So this is kind of like, I'm kind of doing this with the Kaggle competition thing, but kind of saying this is what kind of the general idea what you would have for your end of module project. So the first thing you want to do, like remember, is like your data science lifecycle. So we have some frameworks that are considered, for example, like Awesome and CrispDM, which we'll go into more detail like later on in the course. But the main idea essentially is that we have data, we're kind of acquiring the data, we start with our business understanding. So understand like what's the point of this. In Kaggle competition, we're gonna kind of skip over that. But in your end of module project, that's what you'd want to consider and stuff like that. Sorry, a little error popped up on my screen. So business understanding, so we're gonna kind of skip over that. But then you just talk about data understanding, like, basically like getting this data, right? Getting this data and then cleaning this data. And then I don't actually like this diagram, unfortunately, from this. That's okay. I think this is gonna make more sense. Well, I'm gonna use what I have, sorry. So you can kind of things like we have our data preparation, which is kind of like aggregating the data, loading into there. And then we have like data exploration, which is kind of like looking to see what's in there, see what's around the data, do different graphs, explore a little bit. Might notice like things that are kind of dirty and stuff like this. And then you might go into data cleaning itself, like making sure we get rid of null values, all that good stuff. And then feature engineering. So feature engineering is kind of the newest part for us because we're doing prediction. And this is kind of stuff like deciding what's going to make a good features for our prediction for our model. And then it comes down to actually modeling the data, right? So we model with the data, see how well that makes predictions. And then we evaluate that model, see how well it goes. And then we might literally reiterate onto data cleaning or even modeling. Like we might go all the way back even to the data exploration. And so you kind of have this iterative process. So the reason why I pulled this guy up here is kind of, you see this general like circle, but you can see there's a little bit like back and forth, is that you might go from the modeling, it's like, ooh, like modeling and evaluating, that didn't do that great. You might go back to data preparation and kind of reorganize how your data is going through, and then do modeling again and go through again. I don't like how this evaluation is actually going back to business understanding. I would say evaluating first should probably go from modeling to evaluation to data preparation again. So you might kind of reiterate on top of this. But just know that basically these parts are fluctuating, right? Like there's not like a clear, like, oh, you just go this, and then done. It's going to be much more of like iterative process. Okay, cool. So I wanted to point that out. So we're not going to worry about that too much because we're just going to have 30 minutes to really do this really quickly. So real quick, we're going to do data preparation. So we're going to load the data. And so I'm going to go ahead, let's see what I have in here. I'm going to load this data in here, and I have a notebook next to me so I can make sure I don't take too much time. So we already imported pandas. So we're going to upload the data in there. So we'll do, let's say DataFrame is equal to, I'll call it my data. And then we're going to do pd.read CSV. And this is going to be, I'm trying to remember what I called it. Oh, data. Duh. Okay, so data, and then this is Kaggle competition. And then this is going to be, we're going to do the train data, right? So this is what we're going to train off of. So this is all the data that we want. So I have my data, so that should be good. And then let's go ahead and see, what's it, my data? Let's just check it out, right? So really quickly, we're like, okay, cool. We got ID, host name, so we can see some numerical data right here. We can see there's some missing value already at the very beginning, so we have to deal with that. And I'm just gonna do some really quick, simple stuff. And last is our price, which is our actual target, right? Just to quickly also check out, we can do df, my data. Let's do .info. So I like doing this because it gives me an idea of like how many null values. So you can see most places don't have any null values, but it looks like last review and reviews per month might have some missing data. So we might have to kind of address this, but it looks like most places don't have any missing data. Okay. So one thing to do is that when we're actually creating our model, we're going to make sure we have our features and our target, right? So usually X and Y. So I'm going to use data frames. Just know that in general, if you look at other people's stuff, you'll tend to see NumPy arrays. But why does it not matter if we use NumPy arrays versus data frames? Because data frames use NumPy arrays, right? So we're just going to use that. So let's do my data. And then let's go ahead and just separate out so we get just the price here, or everything but the price. So I'm just going to do .iloc, right? You guys know iloc. So all the rows. And then all the columns except for the last one. Okay, so that should work. And then the iloc, oops, not ilev, all the rows, and then just the last column, right? And then we'll check this out to make sure this worked. So let's do x.head. You can see you shouldn't have price. There you go. And then let's try y.head. We'll see. And remember, it just grabbed the last column, right? Which is just a series. And just to make sure I can do, and len of y, and it should be 31,000. Yeah, 31,290. And I can see the same thing for x. Okay, so it means that we should have separated fine. All right, so let's see here. Now we have to split it into our train test sets. So like in this case, in like the Kaggle competition, you might not actually do this. In your what's it called, in your project, this might be a good thing to do, but just know that we are doing a holdout test. In the Kaggle competition, we actually aren't going to do a holdout because we want to use all the data we can to train off of it and then see how well it does. But just kind of show you guys what this looks like. I can actually go from X train, X test, right? Doing this test train split with X, Y. So this way we can have our test set, and that's our holdout valid, our holdout test set. You guys all remember holdout versus like cross validation and everything. Okay, so this way we can kind of check it out. And I'm going to keep 20% of it. I'm using a random state so that way I'm consistent every single time. All right, and just to kind of show you guys, right? So xtrain.head, it's just still going to be a data frame, right? But you'll see that some of these IDs are going to be different. Okay, cool. Everyone follow me so far? All right, cool. And again, stop me if I start doing something that you're not sure about. All right, so now we split our data. Let's do some data exploration. So I'm actually going to kind of skip over this because, you know, just considering I'm of time, but I'll kind of just quickly show, you know, you would start looking into this data, see what null values are and everything like that, and maybe just some graphs and see how things are interacting. That's like what you should do, right? But I'm going to skip over that because we have a limited amount of time. But the main thing I'm going to care about is when we get into data cleaning. So I put data cleaning and feature engineering kind of together, just because you tend to go back and forth between data cleaning, feature engineering, kind of doing that kind of stuff. I just kind of makes sense for me to put together. In your notebook, you know, especially for your mod project, you might separate this out just depending what your workflow is and what makes the most sense. There's not a strict rule in this way. And later on, we'll talk about frameworks as well, like Awesome and CrispDM, which kind of just structures how you do your workflow. Okay, so I wrote some notes on here just to make it easier for me. So getting rid of unnecessary features. Let's get rid of some unnecessary features. So let's just check out, I'm gonna put it up here. I'm gonna work off of xtrain just because being good. All right, so here are our features, right? And so I'm gonna say, I'm gonna get rid of ID, right? There's no reason to keep ID, right? This is not something that we like need to keep around. Let's see here. We also, I'm going to like, well, let's just get rid of ID first. I think the rest of it is nothing's unnecessary, but ID definitely wouldn't be, right? So I'm going to put xtrain, let's see here, features. I'm trying to keep things like nice and orderly in this way, so that way I have everything. And one thing I want to do is actually create a function. So this way I can reproduce it. Because remember I have xtray and then later I'm going to create an xtest. I want to be able to use those same functions. Again, for the record, is that later on we'll use sklearn's pipelines. And pipelines are going to make this process a lot easier. But since we haven't talked about pipelines, I don't want to introduce a new thing for you guys to have to deal with right now in doing this project. I'm just going to create a function that's going to do this for me. So let's say def get needed features. Oops. So this way I can just pass in the thing. So I'm going to say like DataFrame. I'll call it my DataFrame. Okay, so this way I don't have it conflict with anything. And I'll just quickly document on here, only keep the features that are needed, get rid of ID. And I might come back to this to document as well, but again, short in time. So return DataFrame, okay, without ID column. Yeah, you can follow me on that. So I'm just kind of documenting like what I'm going to do. So let's go ahead. If I want to get everything but the data, except for the ID column, I can just use iloc again, right? So I might try this out just to kind of double check. Like, okay, let's do xtrain, and then let's do .iloc, right? All the rows, and then just skipping the first column, right? So this should hopefully give me everything ID, and we should see hopefully availability. So this is what we want, right? Makes sense. So I'm just kind of testing it out. So let's just return, and then it's going to be my data frame instead of. Okay, everyone make sense so far? Okay, cool. So then I'll actually apply this, and then I'll have xtrain. Let's call it features. So I'm just defining it so, hey, this is different from xtrain, just from my own documentation set. Get needed features of xtrain. Okay, so this should just get me everything except for ID. Oh, see, I didn't do this part. There we go. Cool. Look good. All right. So let's go deal with some missing features. So, okay, missing features. This is where, like, if you are being really good, like, the right thing to do is like to really think about like what makes a missing feature. You probably don't want to drop any rows at this point, if you can, like, because if you can keep that row and use that for prediction, awesome, right? If it makes more sense to drop it, that's where you drop it, but you'd have to consider also dropping the Y column too, right? Because later on we're going to use that Y labels to actually match up. So to make things a little bit easier, I am purposely going to just fill in missing values. But I'm actually going to go one step further up. So I want to make sure, because what was our missing values? They were missing from here. Last review, reviews per month. So I actually think, oh, there's some right here too. So host name. So I'm going to say, one thing I'm going to shortcut on here is that I'm not going to deal with any host name, like all this stuff. You probably should like think about like ways you can approach this, right? Maybe not host name, but maybe like room type might make more sense, like category. But since these are object file things, and even date, I'm going to just drop date because it makes it easier for me, but you could actually use date as a real thing for feature engineering. I'm just going to drop these parts. So I'm going to go ahead and drop host name, room type, and what was that one? Oh, last review, just because I don't want to deal with the date. Okay, so I'm going to do that first. So we're going to get some numerical features. So I'm only going to keep numerical basically because I'm lazy. I don't want to do extra stuff right now, but you probably should. So just again to go here so we can see this. There's our features, and let's go ahead and define a function. So I'm going to define a function to get numerical. So let's say get numerical features. And what we're going to pass in here is the data frame that we're going to train it with, right? So like, we'll call it my data frame. But then this is going to be, we have to do this later on with X tests, right? So we really should pass in here because we're going to base it on, well, actually, no, we can just base it on here. So my data frame could be X train or X test, right? So I'm going to go ahead and just get, say, return only numerical features. Okay, or say return data frame. Data frame with only numerical features. Okay, everyone follow me so far? Okay, so if I want to get just numerical features, let's say columns to keep, right? And this is where I can use a little copy and paste here. Okay, since I already know xtrain, xtest will always have the same stuff, right? I'm going to go ahead and get, let's see here. I'm going to do this easier. So xtrain features, oops, .features.columns. And so I'm going to copy this guy. See, and the reason why I'm printing this out versus like using xtrain columns down here is that way I can make sure that I specifically say what thing there are versus like using the xtrain stuff itself. I could technically do that, but if I later on train xtrain, that could really mess up how this function works. So that's kind of why I'm doing this. Okay, does that make sense to people? Like why I'm specifically saying which ones I'm going to keep? Okay, I see nods. All right, so I want to get rid of host name, and then what else did I say? I want to get rid of room type, and then I wanted to get rid of last review, just because I think I don't need it. Okay, and let's get rid of those extra commas. I know that this is kind of messy, but that's because I'm a little short on time, so make sure I get it through really quickly. All right, and then if I want to keep these features, right? Oh yeah, Jessica, go ahead.
Just okay, real fast. Could you also do it by data type of like only, yeah, okay. So keeping everything except for like the objects.
Yeah, that definitely would work. In this case, I'm just using it specifically. That way I can make sure that is. The reason why I'm doing that is partly like, let's say, just again, for being a little extra careful. Last review, for example, could be a date. I could later on change it to a date something, like a DateTime object, but I haven't considered that. So if you have your workflow makes sense, you can keep it that way. I'm just being extra explicit just because I know for sure these will be the same. Okay.
Cool, thanks.
All right, so let's go ahead and return just these features. So my data frame, and then let's keep those columns to keep, right? Okay, and then let's go ahead, we'll call it xtrain numerical, I'll put numerics. Okay, so that means just the numerics, right? And then we're going to apply this to get numerical features. And we're going to do it from, what was it, xtrain, oops, features, right? So we already got rid of the ID. So there we go, we got no ID, and you should see that we shouldn't have any objects. Cool, look good, right? So one thing we'll notice here is that, hey, we have missing values here. So let's go ahead and deal with those missing values. So I'm going to, again, create a function here. So let's say def fill. I'm just going to fill in the missing values. So, and this is where I have to be really careful about how we're going to fill this out. So I'm going to fill it out because I'm lazy. I'm going to fill it out with the median value versus like trying to figure out some nice thing or whatever. You could also potentially drop it, but remember, if you drop those values, you also want to make sure you drop the values from the target as well. I'm sorry. Yeah, with your target, column, your Y. So in this case, I'm just going to fill them up with like the median value. So I'll need my data frame, which is the thing I'm going to change. That could be xtrain, xtest, whatever. And I want to pass in actually, let's see here. I actually want to pass in specifically where I'm getting these values. So I think I'm going to call this my train data frame. Okay. And the reason why I'm specifying this is that what I'm going to do is I'm going to use the training data frame, get the medians from those columns, and then fill it in for my data frame, which might be different. Like in xtest, that's going to be different than this guy here, right? So, and then also note is that if the xtest has missing values here, even though there's no missing values in this part right here, like in this training data, maybe they're missing the testing data. I might want to still fill those out, right? So I'm just going to preemptively decide to do this. Again, this is where pipelines are really useful, which we'll again talk about in the future. But since I'm making functions, this is what I have to kind of consider. So let's call values to fill. And this is going to be, so one thing I'm going to do is I can do my data frame. So let's say fill with the median. Say find the medians for each column. And so there's this really fun thing. Does anyone know how to, what we can do, what function we can call in pandas to actually fill in the median, like to fill in null values?
Use a mask, right?
We could do that, right? So we could definitely use like a mask and filtering and doing all this really fun stuff. What's nice is that pandas data frame fill NA. I can just use this because there's a function that exists, right? So less work for me. Again, I'm lazy, right? I don't want to do this extra stuff. So it's good to check out the documentation, but what's really cool about this is that I can actually define which column and how it should be filled. And so note that this is the column name and then what value it should fill, and just do fill NA. Nice and easy, right? So I'm gonna do that. So let's do my data frame dot fill, oops, fill null values, right? Or NA. What do I have? Oh, that's because I haven't defined data frame. So fill NA. All right, so that should be the function, right? Yeah, okay. And we're gonna fill in with those values. So values to fill, and then I gotta define a dictionary, right? So I can actually use a dictionary comprehension, right? So that should be the column name. So I'm gonna say for column in, train, remember, because I'm basing off the train data frame, oops. Train data frame dot columns, I'm being extra careful. And then I can just say, okay, it's going to be the column. So remember how we saw this, the column and then whatever the value is. Well, I can just say then train data frame column dot median. Make sense? Everyone see that? Cool. And that will create a dictionary now of the column name and then some value, which is the median value from that column. All right, so I run that guy in there and let's go ahead. What's my original thing called? Xtrain. So you have to be careful, right? Xtrain numerics. And we want to go ahead and fill, sorry. We have to do fill null values. And then we want to say Xtrain numerics is what I'm going to change. And then I'm going to make sure I'm going to use Xtrain. This seems redundant, but later on, this could be like Xtest, for example. So that's why I'm being extra careful. Okay. So, and then I'm going to call this something new. We'll call it X train filled. Well, we're in Python, so we can use long ones. Numerics filled. Okay. So, I don't know. It's kind of redundant, but like, oh well. All right. And then X train, just to check that it does. Remember, there was some missing values in there. Oh, we got something wrong. So what do we have wrong? Dot head. Oh, I never returned anything. So I got to return this. There we go. So missing values, good. Cool. All right, so we got some missing values gone here. If I'm being extra careful, let's just add a new cell here. Let's do X train numerics filled. Let's do .info. Let's see if there's any missing values. And good, no null values. Pretty good, right? All right, so I'm going to skip over categorical variables because I basically skipped over that anyway, but you might do it yourself. Let's finalize the features. So I'm just going to explicitly say, okay, these are my features. These are my labels so I can make sure. Well, just going to be Y, so we know that. And our features are going to be xtrain numerics.filled. Okay, and that's just me to make it nice and easy so I can later up all the data. Everyone follow me on doing all this stuff? Obviously you would do more, right? Like, but I'm just going through it really quickly. All right, so then I'm just going to model it. So I'm going to use sklearn's linear regression and everything like that. And we're just going to train it. So I'm going to use sklearn's linear regression. I'm going to use my features, my labels, and boom. That was easy, right? So I have my model. And so my model now is actually all set and ready. So now I want to evaluate it. So this is where I'm actually going to check out saying, how well did my model do? And this is where you might do multiple times where you do your model and then actually evaluate your model. Modeling the data in general is like the easiest step. It's like usually your code and you just run it. And then it depends on like what your features were and then evaluating your model. That's the two parts that are going to take the most time. Okay, so let's see here. It's good to observe the model's coefficients. So let's see what the model actually came out with. So, okay, cool. So you can actually see these are different values. Let's see, I'm going to copy over what I had from before. Do I have this? Oh, I wasn't nice to myself. Well, I'll do that later maybe. We could print this out to see what specifically, like in the data frame, like actually say like, oh, display what each of these columns are, but I'm just gonna go over that because I have 10 minutes before I have to head out. So anyway, we have the y-intercept. We could build up the full equation of this model. Does that make sense? Or would you guys like to see like how I can display this out a little bit easier? Would that be good for you guys? Okay, I'm seeing a little bit of nods. So let's just do pd.DataFrame. Data is equal to my model dot coefficients. I'm just gonna do it this way. And then columns, well, that's gonna equal to, because I know already my features, dot columns, right? Ooh, what didn't you like? Sorry, I'm thinking, there we go. I had to reshape it. The reason why, just real quickly, so that I did that, not saying anything, is that, I'll show you guys really quickly why I did that, is that the problem is that this coefficients, right, is all in a line like this, but it's expecting each row to be something separate. So I'm reshaping it. This is a nice little quick thing to reshape it so it looks like this. So I can get one row of stuff. Otherwise it was considered each of those things as a separate row. Does that make sense? So I could have also done, I think I could have done this way too. This is what you probably saw before, where you can have each part like that, but it works either way. All right, at least for this situation. So cool, I got all my coefficients. That's how each one relates. Okay, so I can do some evaluation. I can check the p-value. I'm not going to do that right now because I'm using stats models, but you can actually do this, determine the t-statistic. To be quite honest, it's probably just easier to use stats models to give you that nice, beautiful table. Otherwise, you would do multiple t-tests with saying the coefficient compared to 0. Because if it's 0, that means the coefficient wasn't useful, right? And you're basically saying, okay, how far is that apart? So you use the standard error from that thing. Basically, you're doing multiple t-tests on each feature. That's what that stats models ANOVA table. I will tell you in practice for data science, you probably, because you're not going to use just linear regression, you probably might not even do this. But for your project, since we haven't talked about it, I think it's a good thing for you to check out to make sure your p-values, all of these things are sufficient, statistically significant for your model. But I'm going to skip over that for now. Okay, cool. So let's observe how well the model makes predictions. So I could just do it against the tests, but let's say I do multiple models. I want to see my cross-validation score. So I just put this together right here, and I'm going to use the negative mean squared error. The reason why I have to do negative mean squared error is because cross-validation score relies on the fact that the score, to say it's better, the score has to be higher. Well, the problem is the mean squared error, if it's bigger, that means worse, right? A bigger error is a worse kind of model. So I'm using negative mean squared error. So basically, this bigger that is, right, it's going to be more negative, right? So as we get closer to 0, we're going to have a bigger score, which will mean a smaller error. Does that make sense? Okay, hopefully I kind of said that really quickly. But now I'm going to do cross-validation. So I'm going to go ahead and get out my scores with, oh, get rid of this guy. I don't know why I have this here. So I have my scores, and now I'm just going to display my scores, then how my mean of those scores are, and then the standard deviation. So, oh, that's why I did that. Okay, there we go. So I just took the root mean squared, so that way I have negative of the scores. So there we go. Okay, so you can see here is that I have not a great model. This is like, if you look at this, this is about like the range of the price because I took the square root already. So the price range, like, you know, this is this average error. It's about 239, 275. Not that great, right? As considering that probably most places are maybe even under $200. So my model's not doing that great, which you could expect. I didn't do a huge amount of feature engineering or anything like that. But you can kind of see really quickly how bad that is. And then this is the mean value right here. So this is kind of like the average how it goes through. And then the standard deviation. So this is telling me basically is that if I trained on different parts, how well is it generalizing? And this generalization, actually, it's maybe not too bad. Off of $37, I would say that's pretty reasonable. My guess, I should probably look at the features or my target and see what the target range was already, like what is the standard deviation? We can probably do that really quickly. So if we can do like y, that standard deviation, you can see like there's a huge wide variety of like standard deviation right here. And then let's just do y.mean, which I think Yeah, the mean is like 151. So my error is bigger than like that, the average of the y. So not great, right? But that's okay. At least this way I can see that it's generalizing relatively well. Like it's definitely the standard deviation of this. I might want to check it, make sure like it's not skewed in any particular direction. It might be, but I think this seems reasonable. At least it's not fluctuating between each part less than $50. Was $50 different? Like $50 difference, I would say is like my threshold for like what would make sense for this thing. If this standard deviation was up to 5, I'd be like, whoa, like this is a really good model in the sense of like generalizing really well. And then I would try to repeat this, right? See what our error is, which again, the root mean squared error is going to relate to r squared. So I can kind of use this as a proxy of comparing models. And then you look at the standard deviation to see like, well, how well does it generalize across each validation? Okay, does that make sense? Cool. So if we all feel good then about this, we can then do our actual test set, right? So we can actually try this out. So let's see, I have about 5 minutes left. Okay, I'm going to hold this off just for a second, just to make sure I show you guys how to save your models. So let's say we test this out, we're like, oh, cool, our model's awesome, right? Like, well, let's say it's not awesome or something, we're going to do a different model. It's a good idea to save your models. So just like saving the whales, we should, happy Earth Day, we should also save our models. So the way we save our models, Pickle or JobLib, I think the curriculum shows Pickle. Am I right on that? For the record, JobLib is more efficient, but I'm going to show you both ways. So just kind of knows that JobLib tends to be the more default one nowadays. And it's not that different from like Pickle. It's based off of Pickle. So I import Pickle. So we kind of pickle into a jar. Think of that. That's how I think of like how we're saving our models. We're pickling. And so we're just dumping our model. So remember my model is my linear regression. I usually save it as a .pickle. This is just one way to do it. There's a couple ways to do it, but you can see this is the name of my file that I don't have yet. WB is just saying write binary or byte code. I don't know, whatever. Basically, like you're writing stuff in bytes and stuff like this. So I'm running that. And then if you want to later on to compare a model, we can actually load it up right here. So a good thing to do is document on your file name what this model represents. So if you did some specific thing, you might actually have like my model, I wouldn't probably call it Pickle, I would say like my model, like simple solution, something like that, or like something more descriptive. So that way you can come back to it and then load that file in here. And then if you want to load it, you can actually take this guy out. And what's cool is that I can actually check out my model now. So model loaded, remember we didn't have that before. And you can see that, hey, there's my linear regression. So I can actually take this model then and do stuff with it. JobLib, very similar, but again, technically a little more efficient. I actually think it's a little bit easier to run too. So JobLib.dump, my model, name the model, and then load it. Okay, same exact process. So nothing really changes. Okay. Cool. All right, so let's kind of go through there. It's like, okay, like we do our whole thing, we model it. If you wanted to do your test here, so see if I can do this really quickly. I might go a little bit over, but that's okay. I have my X test, right? So we still have X test, right? Oops, not test, all right? So we want to actually see how well this does, right? So we can make predictions off of this. So this is where you might want to keep like basically what you were doing in your functions. Because now I need to get rid of this ID, I need to fill in the null values, like all that crazy stuff, right? That'd be a pain, copying, pasting everything. I made it a little bit easier by making some functions in here. So let's kind of go through, I have my fill null values. Well, let's go right at the top. So I'm just gonna get needed features. And if I documented well, it makes it really quick. So I'm trying to minimize some of these things, okay. So let's say get needed features, and then this is going to be X test. And that's gonna return a value. And then outside of that, see, this is where I have to make sure I get the right order too. Get numerical features. I get needed features, right? Oh, we did that. So this is, again, where pipelines are super useful, because then you don't have to like do what I'm doing, whereas like I have to look at each individual one and see exactly what I need to do. Get numerical features, fill null values is my last one, right? I think I only use those 3, right? You want to remember? I think those were the only 3 functions I used. And then I believe this is where the fill null features are important, because I need to give it the train data frame, right? So this is going to be that whole X test that's been modified, and then I'm going to fill it in with that specific X train, which should be X. If I was smart, I would have put that in already. numerics, right? So that's going to be everything that's before it's filled, right? So that's my training stuff. So let's do X test final. And if everything goes well, we'll be good. Yeah, no errors. Okay, so look at that. First try. Oh, beautiful, look, and no missing values, right? Yay, okay, cool. So now we can actually do some predictions off of this, right? So just to kind of go off of like a model evaluation, we have our myModel.fit. What's really cool. All we gotta do, we have my model. We put in X test final, and then we don't do labels. Instead of .fit, we do .predict. Boom, okay. So now we have our Y hat. So these are my predictions off of X tests. And then we can actually evaluate, compare, this is where I'm out of time right now, but you would say you would compare Y hat versus Y tests, right? So you would kind of see how those differ from each other. I think in this case, I can probably subtract it because it's just the same thing. Residuals. That's not going to work well because I have it as this. Oh, because it's not Y tests. It is. Sorry, I'm thinking to myself. Why is this the same? I'd have to check what I did, but the shape should be the same. So, sorry, it's going to bug me if I don't check it. Oops. Yeah, that should be the same. So I might have mixed something up in here. I might have to check my functions. This is where debugging comes in and everything like that. But yeah, I don't know why. Sorry, it's driving me crazy, so I have to check it. Okay, something went wrong with what I did. But the idea there is that we have, let's say, X test final. Yeah, I did something's up with my guide here, so I'd have to make sure that I'm having some data leakage right here. So one of my functions here was not correctly created, so I need to make sure that was correct. But I'm not going to do that right now because I don't have time. So there you go. That's a really quick way of doing this. I also have one that's pre-filled that I know works. So I'm just going to drag it over because I have this open just in case I really messed up. But I'll also load this into the repo too, so you can kind of see a little bit what this happens. But just to show you that does in fact work. And it more or less follows the same structure. I might have changed some stuff, but yeah, same again, standard deviation, stuff like this. And they can do a prediction stuff on top of that. Okay. All right, everyone. Well, again, just remember no study group tomorrow. I will be dropping my wife off at the hospital, not to deliver, hopefully, just to do like, tests and stuff and check on the babies. But I will see you guys if I don't have one-on-ones with you. Well, today's Wednesday, so hopefully I have one-on-one with you if I haven't already this week. But if not, I will see you around on Slack and everything. All right, take care.
Thank you. Bye.
You guys, thank you.